Adam, for taking your time to present here. One more presentation, and yeah, I really appreciate it. I'm really looking forward to this one. We have been talking about this for a while there in the forums already, discussing this project. I'm really looking forward to get to know more in depth what is happening and how you're using IceVision here as well.
Okay, so I think there are a couple of things we've been doing with these weekly presentations, and I think one of the things we've been doing is using them as opportunities to get to know each other in the community a little bit. So I'm going to start by just saying a little bit about myself, I think, and then get in a bit to the project and the problems that I'm working on. So I'm Adam. I've been using IceVision off and on since last fall. So I think between the time I first looked, it was and tried to get started, it was called Mantis Shrimp still, and then when I returned, the name had changed, and we all know what's happened since.
Yeah.
I've been knocking around sort of the machine learning and AI space for quite a while. I have actually a PhD in artificial intelligence from UT Austin. My very first co-authored paper was actually in machine learning, although it's a bit embarrassing to think of it as being machine learning, given where things are today. After I did my PhD, I spent about 5 years at the Stanford Knowledge Systems Lab. After that, I spent 5 years in a industrial sort of corporate research and development and then technology development context at Schlumberger, which is in the oil and gas industry. But I basically, I did information bits, not drilling bits. And about 16 years ago, I came to the UK, where I live now just outside of London. I've been working at the British Library. And at the British Library, I've done a bunch of fun things. Many of them are relevant to what I'm talking about today. So I started out working on digital library technology. I was responsible for enterprise architecture for a while, and then I did something referred to as digital scholarship. Along the way, I built their digital preservation capability, their research data capability, their digital scholarship program, and did a couple of big R&D, funded R&D projects. I also, sort of entertaining for me, had responsibility for some big collection areas in the British Library. So the ones that are most digitally interesting, so maps, sound, newspapers, photographs. I also coordinated their digitization activities for quite a while. While I was there, I also built the digital scholarship team. And that was quite unique for libraries because it was capable of working with some of these advanced technologies that we're working with in the context of IceVision. So we provided some large data sets, including historic images, about 1 million of them. We made public domain on Flickr, 65,000 historic volumes we digitized and made available with Google. While I was there, I also helped the library to sort of bring the Turing Institute, which is the UK's National Institute for Machine Learning and AI, into the British Library. And as far as I know, the BL is the only national library in the world that's co-located with a national institute like that for machine learning and AI. We did some fun projects with the folks at Turing, including setting up, and then I was co-I for the Living with Machines project, which looked at applying machine learning primarily to large cultural data sets in the context of humanistic research programs. And while I'm no longer at the British Library, I remain on the advisory board for the program. I also had the opportunity to found along the way two kind of interesting not-for-profit organizations. One's called the Open Preservation Foundation, which develops tools or open source tools and technology for digital preservation. And the other is called Datasite, which works to integrate research data more tightly into the scientific record through making data more findable and citable, especially. Those organizations have both been going for over 10 years and continue to thrive. I stepped down from the British Library about 15 months ago from my one of those management roles there as head of digital scholarship. And that's given me the opportunity to actually return to some of the more technical focused work that I did earlier in my career. And I have this sort of passion around finding new ways of and new uses for information in a wide range of forms. And at the moment, that's taking shape in this thinking about document analysis using machine learning. It's a problem I've been wanting to work on for the past few years. And oops, my screen has disappeared. There we go. I'm going to return it to the full screen. Good. I've been having a lot of fun looking at it and working on it in the last 6 months or so. So I'm going to spend a little bit of time talking. Some is going to be about the problem area, and I'm doing that partly because I think it's not this, it's not the absolutely bog standard application of especially object detection technology. And then I'll talk a little bit about how things have been going, some of the challenges that I've come along, and some of the things I've been fussing with to overcome them. So I think we sort of all recognize that most of the world's knowledge is conveyed and preserved in documents.
So, Adam, just really quickly, currently we cannot see your screen.
My apologies. It seems that when it came out of, thanks for telling me though, yeah?
Yes, yes.
Sorry, we're gonna have to present a new window. I'm gonna select the window, I'm gonna share it, and we're going to full screen it.
Yeah, now it's coming. Nice, yeah.
Great,
cool.
Thanks. Right, good. Right, so much of the world's knowledge is conveyed and preserved in documents. It's been going on for a long time. On the right-hand side of the screen is the well-known cover of the first issue of the Royal Society's Philosophical Transactions, which is generally taken to be sort of the first of the modern published scientific journals. What we've seen, especially over the last century and a half, is an increasing trend to include information in the forms of tables, charts, diagrams, figures, things like that. To some extent, that's driven by improvements in publishing technology over that period, especially in the last, let's say 50 years, as we've been using digital word processing. And as a result of that, we've seen a lot of key information move itself out of running text and into things like tables, figures, and in terms of journal articles, we also see supplementary information materials as well. A nice study I read recently of looked at biomedical articles and was looking for genetic mutations mentioned in them, and in fact found that fewer than 10% of the genetic mutations that appeared in the articles actually appeared in the running text. So this shows us not only is document analysis critical, but dealing with things like tables that appear in documents outside of the running text is absolutely essential. And that's not just true for modern stuff. I'm also quite interested in historical materials as well. While I was at the BL, there were some fun things that we looked at. One was there's a project to digitize ship's logs from the late 17, early 1800s, which have really valuable information for back-checking models for climate change, for instance. Or the Financial Times has a century of very fine-grained economic data, financial data, that they published, but for the first 50 years or so of that's been in forms that wasn't readily accessible. It's been digitized, but the digitization doesn't necessarily make it useful and semantically meaningful. Another nice example with the Living with Machines project I mentioned is around working with historical census data. Again, incredibly detailed, rich information, in that case about people and what they did and where they lived, been locked up in paper documents and now locked up in images, opportunities to extract that and make it more meaningful through more sophisticated, better document analysis, really exciting for historians. There's another important area that we see a lot, which is around accessibility. Accessibility requires you to be able to understand what's on the page and read it out, automatically. And this is a nice example, both a positive and negative, as we'll see in a moment, on the right here, of a screen reader talking about a table with rows and columns. And of course, any kind of business critical data-driven analysis and inference requires information machine readable form. A lot of business information, however, is locked up in documents, even if they're things like Microsoft Word or PDF. They're not necessarily in a form that we can then do interesting reasoning and inference with. So having said that, there's a perspective that says, what's the problem, mate? We've got structured documents, HTML, Office, OpenXML, ODF, LaTeX, they all provide rich structure in the document. They tell you what's a table and what isn't a table, what's a figure and what isn't. I did mention in the front, I spent actually a couple of years on the Office OpenXML Standards Committee trying to make sure that things were as transparent and understandable outside of the context of a particular application as possible. But what we find when we look at tables in particular is that people don't use the structure that's available to them. I don't know if you've ever looked at, I'm sure all of you have looked at HTML tables, right? That are used to design elements for complex layouts on the web, right? They have nothing to do with tabular content. They're only to do with getting GIFs to line up next to each other in the proper way. I've seen Word documents where the tables were actually little graphical image boxes that have been carefully lined up with text inside of them so that they look like a table, but are actually a display of image boxes. Or columns where you see people have lined up, indented lists on both sides on different columns in a table so that it looks like there's a tabular form, but actually structurally there's a table of, 2 cells in 2 columns, whereas to the end user, a human looking at it, it looks like dozens of different cells. So I guess the summary there is people don't consistently use these structural elements. And in particular, people lie to the software that they're using in order to get the visual effect that they want and better communicate with people. Another response to kind of the what's the problem thought. Whoop, I think I've just done it again. I'm going to share my window again. Share that and go back to the proper size. Okay, OCR is awesome, right? Who needs more sophisticated techniques or even the structural ones? And in fact, I'd say OCR is awesome, but it's really awesome for a Latin script in running text in modern printed and digital documents. OCR is awesome for tables as long as every cell in the table is fully demarcated with the grid line. It's awesome for complex forms and structured content, like invoices or library cards, but actually only if you can invest a bunch of additional, handcrafting time to get it to work. And then it will be repeatable from, this month's invoice to the next from one company, but won't work very well when you get an invoice from a new one. I'll say OCR is, not at all awesome for things once you get out of this region. We did some fun projects looking at digitization of Arabic text, which is not in very good shape. We also did some on early Bengali, also quite interesting, not in good shape. Most tables found in a business setting are not very regular. OCR doesn't work well for them. And any kind of very varied format where you get different structures on each page doesn't work well there. So as I was thinking about the problem, the question arises, is it an object detection problem, or what kind of a thing is it? What I observed is people are actually very good at document layout analysis, right? You can give me a page in a language I don't know, a script I don't even read in a domain that I don't understand, and I can very easily tell you, where the blocks of text are, the figures, the tables, these sorts of things. And in fact, most 10-year-olds will be able to do it as well. So that suggests to me that it's a pretty good, if it's like a 10-year-old can do it without any training, it's often, or minimal training, this feels like a good machine learning challenge these days. And another thing I notice about it is that, the visual representation beats the text and the structured document format. So you don't really need natural language processing to get pretty far here. You should be able to do it by looking at it. When people work in this area, and there are lots of folks who are, they do sort of a typical set of document layout elements they'll identify, be text, title, list, table, and figure. The nice thing about these objects is that they're all quite square and usually well aligned with the horizontal and vertical, so bounding boxes are perfect for them. So all we need is like some massive, huge data sets and we'll be in good shape. And in fact, in the last couple of years, and really just the last couple of years, this has happened, right? Some massive large data sets have become available. This table on the right-hand side here shows amongst some interesting data sets, a couple for ICDAR, which is the International Conference on Document Analysis and Recognition. Back in 2013, they ran a competition around table detection. They had a massive data set with 156 tables in it. In 2019, they had 3,500. In 2021, they're running it again. They have hundreds of thousands. I think it's 350,000. So that explosion of the size of the data sets in the last year and a half are really exciting. And I love the way that they've constructed, and people have been constructing these data sets. So I think it's quite, it would make a great talk itself, but it's worth a mention. They're primarily generated from large open source corpora of typically it's scientific documents. This is because those are available. And some of the big sources come from arXiv and PubMed, PubMed being the biomedical literature. In those sources, you find that most of the content is in LaTeX or Microsoft Word documents, PDFs. So you can, what people have done is they've taken the LaTeX, the doc and the docx, and they hack them. So I said it was easy to do analysis if every table, cell, and figure has a bounding, a box, a grid line around it. So they actually just modify the original documents to introduce grid lines, typically in colors that don't appear otherwise in the document, and then they can go and use fairly straightforward techniques to find the locations of the bounding boxes. You can't actually tell very much about where the boxes are going to show up if you look inside the structured document format. You've really got to run it through the whole application in order to come up with the proper location and appearance. So PDF ends up being the arbiter there. This means that the bounding boxes are super accurate, which is great. The labels are not always perfect because, as I say, people sometimes mislead the software in order to get the effect that they want. But in these particular sources, in this sort of scientific journal article space, there's not very much of that. People have tables, they're labeled as tables. The publishers want them to do that so that their articles show up properly. Okay, so that's about a bit about the why this is an important and interesting problem. A little bit about the data sets that are available. I'll mention a little bit about what I've been doing. So I've been building a system for document analysis and table extraction. I've been calling it Dante. And on the left-hand side, these are sort of the four primary tasks that we're working on with it. So page component and analysis, that's about detecting and labeling the objects that are on the page, and that's basically what I'm talking about today. Then there's extracting the page components, which is basically, that first analysis thing, we're using a very small number of classes and we're detecting the objects. In the second step there, we extract the components, we do additional analysis and additional classification. There are lots of, in the first category, we may just identify figures. In the second one, we may say, here's a bar chart, here's a diagram, here's a schematic, here's a photograph. We'll go into greater detail. Third is looking at, and fourth are looking at tables in more detail because they're so important. One is to figure out a table structure, how many rows, how many columns, how many cells, where are they, do the cells span columns, do the rows span, do cells span rows, and so on. And then lastly, using that parsed information, trying to extract additional semantic context from the cells. On the right-hand side, I've listed some of the components of the system as it's emerging. So I'm using IceVision, of course, for object detection. I've been using the FastAI library for image classification and table structure analysis, their training loop. Development and deployment is done with Docker. I train on these fairly large-scale open source data sets and then fine-tune with more relevant business-specific ones, and deploy the various component services through a microservice API. So I thought I'd make a couple of observations about properties of this specific task. Okay, so I mentioned there are a large number of instances, large public data sets. There are a small number of classes. For the document layout analysis, there are 6. Unlike analysis of photorealistic images, for instance, size, scale, and orientation really matter here. So, a picture of a dog in a distance or a dog close up, it's still a dog. If a page were to have something that looked like a tiny table that was only 5 pixels on a side, it's not a table, it's something else. The size makes a difference. Key features can be pretty small, actually. Things like footnotes or small running titles, as you find in journal articles. And they sometimes disappear at lower resolution, so that's important for training. The objects are quite densely packed. They have some interesting properties. They don't overlap, for instance, so table cells don't overlap. One paragraph doesn't overlap with another. But they can have partonomic relationships. So, for instance, you might have a table and in each cell is a figure. I'd like to, if anyone has ideas of good handling for partonomic relationships among objects, that's a sort of a discussion topic for later. For the most part, color doesn't matter. The pages I work with are basically black and white. You can do this task with grayscale images just as well as you can with colored ones. Orientation, unlike with sort of natural photographs, is very limited. You basically have the right angles and that's about it. And the distribution of the classes is extremely skewed, and this is a difficulty for training. So most of the items are text blocks. There are relatively few figures, relatively few tables, and while there are a fair number of small titles, titles that occur on title pages or the heads of articles are much less in evidence. So training, the training set I'm using with most of the time, the full thing is 100 gigabytes, about 350,000 images, and about average of 10 objects per page, so 3.5 million objects. I typically have been working with a subset of it. I usually now work with 100,000. High accuracy is required. You know, small objects like titles turn out to be very important. Little overlaps between or getting the bounding boxes a little bit wrong, where that means that you don't include blank space but include adjacent text, is disastrous. And this boils down to a high desire for precision and recall. And people have been working on this problem for a while, and I've seen numbers like 95 MAP, which seems doable if challenging, but the harder thing is the precision and recall on the small objects. And I will come back to this at the end. I've quite a few questions about, to what extent is augmentation important here? What kind of augmentation is going to work well? Some people do blurring, which seems to be useful for certain approaches. Lighting and coloration might be useful to not have a system become overly reliant on black and white. Many business documents have colors. Rotation a little bit seems to be useful, not so much for these constructed data sets, but if you're working with digitized images where there's some rotation, also useful. So, okay, now I'm going to sort of pause there, switch a little bit, and just talk a little bit about some of the issues that I've had with dealing with, I call them large, I'll call them large-ish data sets using IceVision and FastAI. So first point is I want to use all the data, but frankly, 350,000 objects in an epoch takes too long. What are the issues? You want to have regular reporting and metrics. You'd like to have weights and biases integration to see how things are going. You'd like to have checkpointing. You don't want to have something blow up 345 images into your epoch and lose your work. You like to do things like learning rate reduction if your system's plateauing. And in FastAI, in any case, these things are primarily keyed to the epoch, right? So you wait till the end of the epoch, you pause, you do some validation, you do some other things, you save some checkpoint files and so on. So I thought about going in and sort of modifying or reverse engineering the FastAI callbacks and moving them from where they currently happen at the end of an epoch to some point during the epoch, and then you could use lots of things, every 15 minutes, every 10,000 items, every so many batches, these sorts of things could work. And I ended up not doing that. And I think it's partly because a chat I had with Lucas a couple of weeks ago, where I was saying, I'd really like to do something where I change the data every epoch, run through all of the data during a sequence of epochs, but not within each epoch. He said, you could just hack the data loader. Set learn.dl at the start or the end of an epoch, and that should work. And I almost did that, and I ended up backing off from that design, partly because data loaders are fairly complex objects, partly because IceVision puts the data loaders inside of the modules for different types of packages. So there's a different data loader for faster-rcnn than there is for efficient det, for example. And then I realized that actually you could customize the data set and the learner would sort of never really know the difference. So I implemented two different data sets to kind of provide this behavior where epochs would be relatively small. I typically use, say, 10,000 items in an epoch, but that they would consume a much larger record set if you want to use IceVision records as a touch point there. And so one was to just return an item at random every time it's requested. And I actually love this. I've not done yet, gone back and done an extensive test to see how it affects the performance, but it has this nice feature of being, a very small number of lines of code, and in some ways being very, very robust and sort of asymptotically giving us the same behavior. And then the other thing, the one I worked with a little bit more, is what I'm calling a multi-data set, where you take a large record set, in my case, say 100,000 or so, and you then chop it up into epic size. So in this case, 10,000 item chunks, and then use one of these epic size chunks at a time. And I use a callback to, do a little initialization before training, and then do a little, advancing a counter before each epic. And that seems to work fine, actually. It was very straightforward to implement, and it gives me the overall behavior that I was looking for from the system. Run through PowerPoint, then we'll switch to a browser and show you some bits and pieces. Then the second couple of observations I have on this slide. So so parsing large COCO files, which is what I've got, so ones with 1 million plus bounding boxes, is very, very slow. Okay, it takes hours. And most of that time is spent checking image files on disk. In fact, the way the parser looks, every time it, at each bounding box, actually, it checks the file to make sure that the dimensions of the image and the image are correct. The image file is there. So that's super slow. So I patched out the file system access, and that reduced my multiple hours down to 10 minutes, which was tolerable, but still, horrific if you're, in the sort of development loop where you're trying things out and tweaking as you go along. So then I think some of you will be aware, but maybe not all of us, that the parser has a feature where you can provide a cache file, and it will cache the results of the parsing to disk in a pickle file, which is great. Another 60x speed up. And so now loading the parsed file for the takes 10 seconds rather than hours. So cool. There are just a couple of niggles that I've had with it, and this will go into issue reports tomorrow. I haven't had a chance to do that yet. One is that you can't move. Basically, it's that you can't move the cached parse files between architectures or directory structures. And I happen to have been moving between a Linux and a Linux and a Windows environment for doing development and training, and I was surprised to see that my my pickle files actually didn't port from one to the other, and that's because they're using pathlib.path objects for file references, and the Linux paths don't work on Windows, and the Windows don't work on Linux, even though they both are implementing the POSIX. They both inherit for the POSIX file path. So a suggestion that we can implement would be to have the pickle files actually the parsing, the parser cache routine to use strings rather than pathlib objects, and that will not only make the pickle file much stronger, it will load much faster, and will also be cross-platform. The second problem area, and I think all of you will have experienced this, is large data sets. I don't know why, but they always have errors, right? Even when they're auto-generated and widely used, they have errors. In fact, I think that one of the reasons there is that the people who produce them, once they've been used the first time, think that they, to do good science, they have to make them sacrosanct and precisely the same as used before. And this is unfortunately not quite the case, because of course everybody uses them, has to filter out the errors, and they may do it in slightly different ways. And so you'll get, well, everyone had the same input, they're actually training and comparing their systems on slightly different derived forms of it. So what do we do there, right? We use autofix in IceVision. This is an awesome feature. I love it. But again, for large COCO files, it's pretty slow. It also confirms image sizes by checking the files on disk. And that's once per bounding box. Again, I patched that out, and that resulted in a huge speed up of autofix, like it's around 100x. And this will, of course, vary with your file system and your processor and so on. And that's great. There's some things that and when you then cache the results, you're kind of okay, but it's occurred to me that it actually would be super helpful to have a way to save the corrected data set out and then replace it so you basically don't use the error, including one next time, or if you want to republish a corrected version or share it, lots of reasons to update the original data set. And I guess what that comes down to is autocorrection is great, but it should be done once per data set, not once per training session. And that's kind of a little shift in mindset that I think we should consider. And I think that will enable us to introduce even more interesting features in the autocorrection routines. So I think that's where I wanted to stop there. I feel like I've been talking slightly longer than I intended to. My apologies for that. I hope it's been interesting enough so far. I'm now going to just switch over to my browser and talk a little bit about how things are going, and a little bit, maybe take a look at a couple of bits of the code. So I am going to switch to my browser. Let's see if this is going to do it. I don't want a tab. I'm going to have to change every time. I'm going to switch to a window. Okay, so hopefully that's showing my browser window. And hopefully what you're seeing there is a weights and biases screen. So first I just say a couple of things about training. So it's going somewhere in between like pretty well and super frustrating. And I think this shows it pretty well here. So if we look at our COCO metric, this is, freaking awesome for identifying dogs and cats. So this is a COCO average precision metric of 0.887, which is pretty good. This is using efficient-det D3. It was trained on 10 epochs of 10,000 items in each epoch. This is comparing there are two training runs on here that are visible. The second one actually follows from the first one. So the red line is actually, I trained from the base through the first 10 epochs, and then the second one I trained today, I picked up and ran another 10 epochs with it. And what you'll see there is that there's very little advance on the second training run. And we'll come back to that, but this is one area I really hope you guys can give me some hints about how to do better on. How did it do? Let's see if we can see this a little bit. I think we can full screen this. Yeah. Not exactly what I want, but let's leave it at this for a moment. So you'll see here we've got images titles and lists, I've just filtered it because if we look at text, everything's a text box. So we're going to take out the list. We're just going to have titles, figures, and tables here at the moment. And you'll see this. Oh, I didn't know why. I know why it's giving me this 3. This is, looking kind of like the right sort of thing. The tables are correctly identified. This set of figures looks pretty accurate. That's not so bad, and that's looking at both the ground truth and predictions. Let's get rid of the ground truth. Sorry, this is pretty. I'm going to come back to this in a second. The one in the middle is from a very tiny run that didn't do any training and it couldn't find anything. That's why there's nothing showing on the middle one. The one on the left and the right are both from fairly good training runs. You see the figure is identified at a very high level of confidence. The table, the titles with quite a bit less. I'm going to close that. Close that. I'm going to go to the recent training run. And I'm going to see if, where's my media? Just taking its time. I'm going to go down to the predicted images again, and we'll take a look at what we've got here. So you can see these are coming from biomedical literature, typical sorts of pages that you'll see from it. And we've got the ground truth closed off. If you can see this well here, we're going to turn the ground truth on, and you'll see there's not a lot. There's a bit, but there's not a lot missing. So I'm going to get rid of the text. And you'll see for the most part, and I'll take out the list as well. We're just going to look at titles, tables, and figures. It's looking like pretty good. There's not much that's being missed there. So it's like pretty satisfactory. If you look in a little bit more detail, you'll find that some of the titles are being skipped. I really like this feature of the W&B interface, but obviously it would be nice if you could make the images bigger, and it doesn't seem to be offering us this option. So you can see it's missing quite a few text blocks, especially ones that are close to and under figures. So these are things like captions. So these are areas that I'm hoping the training will improve on in the next period. Okay, I'm going to close that. So my big question for you guys when we come back to it is, what can I do? What ideas do you use to improve training results when you're saturating like that? Okay, so I will now just pop over. I mentioned deployment. I'm deploying with Fast API, which I've really quite enjoyed. And one of the things I like about it is that it automatically produces the OpenAPI or Swagger documentation, which is readily available. Box there, so you can see this API is implementing just 4 methods. There's show the models, page components, and page predictions. And if you hand the system like this in the API to somebody, it's really nice for them to be able to pull this up and play with it and say, all right, let's look at that post thing. How does that actually work? And it, lists it in a very convenient fashion, and it lets you try it out directly through the documentation, which is a fantastic feature. So you can go in whatever, pull up an image, in this case, execute, and see the bounding boxes that are being returned for the content there. That's less useful. Sorry, I'm going to scroll down to the next method. Unless you know what the bounding boxes are supposed to be. Let's try out this method, which shows the results. Choose an image file. Open something quite at random. And shows the result. And I'll note this is the model results here from an older FCRNN model, which the one thing I wanted to do before we met today was to update the model in the running version of the app, and I just didn't have a chance to. And you can see that the we chatted with this about this with Lucas previously. For data sets with relatively small numbers of categories, it's much better to stick with a single color throughout, because then you can quickly identify things by the category, by the color, rather than showing the labels, which in this context where objects are quite dense become heavily obscured. Okay, so that was a little bit about, this is running on a Docker image in a server in Texas somewhere. I mentioned the data sets. This is my random data set implementation. It's super fun. All it does is it just picks a record at random and continues. And it needs to know its length because the data loaders check the length of the data set, but don't actually, but only visit each item once, so it works fine. The multi-data set is slightly longer, but actually, pardon me for skipping around, but actually just a little bit more. It takes a sequence of a list of record sets and just marches through them as you go along. The callback down at the end for folks who are not as familiar with the FastIA callbacks implements a couple of methods, something that's called before fit, and something that's called before training within each epoch. So let's see, so I've showed you a little bit about the results, a wee bit in the code there, a wee bit how it's runs and is implemented. I'm going to stop sharing there. I had a list of questions, so I'm going to go back to my list of questions because I think there are things where I'm hoping one of you has some ideas and can help me to figure out how to do things better. Let's see if I can do that. Window. Good. So people, please take yourself off mute. I've been talking to myself for quite a while now, and I'd love to hear from you because I know some of you are have deep experience, and you may have some suggestions as to how I can do things a bit better. So three types of questions I have. So one is about models. So as we know, there are many models out there. We also know that IceVision brings together an even more enormous set than you would find in any other single location. So the question then is, which models do you use for what sort of applications, right? I started out using faster-rcnn because why not? It has actually pretty good performance in a bunch of ways, even if it's a bit slow in prediction. I recently switched to efficient-det, D3. I'm getting slightly better predictive performance out of it, and it's slightly faster for doing inference. But maybe I should be using something else for the kind of problem that I'm looking at. Maybe someone has a thought there. Second question area is around training. I'm getting stalled, and I'd like to know how to get past it. And one little sub question here is, look, do a couple of hours training, produce something, you'd like to go further. I find it hard with Fast AI to get a good quality continuation. I find it usually works better if I did twice the number of epochs from the start rather than stopping and restarting. I suspect there's something about how the optimizer gets reset and the long-term scheduling that they do, and there's something I don't understand about it quite. And then another one is, of course, about augmentations. Some of you may have some good insights into better augmentations and approaches for this particular problem. And then on the right, I've got this question about, it's just, what do people do around configuration? I've gone through a couple of iterations here. I'm currently using OmegaConf. It seems okay. I notice W&B, now that I've integrated it, has a nice config capability. What are people doing for that they really like? Same thing for command line scripts used for training. What do people see there that they really like? So please, if you have any thoughts, let me know. Can people unmute themselves?
Yes. I have a little question, Adam.
Sure.
So what was the AP for faster-rcnn? And then the efficient data, I have the impression you said 90?
Yeah, let me show you what I'm getting for efficient data. Unfortunately, we'll have a hard time showing you the detail for the previous ones. Let me just, if I go to here and logs and share my window browser. Does that work? Are you seeing my browser window again?
Yeah, we can see your browser. Maybe if you can increase the, otherwise it's fine.
I can, like that.
Yeah, perfect.
Okay, so you can see how that's looking. So here's the most interesting area. So you can see that large objects are pretty well nailed. 0.93, not going to get, you can hardly tell the hairlines are in different locations with that. Small objects I'm not happy with at 0.33, and the medium-sized objects are like just barely acceptable at 0.6.
Yeah.
And then the recall numbers, the large objects is very acceptable, but the small objects recall at 0.5 is not very good.
Okay. And when you compare it to faster-rcnn?
So I don't have a suitable comparison. I didn't, I just switched to as we do these things, I just switched to using cloud compute for the next couple of weeks at Jarvis. And so I've been training Jarvis AI, Jarvis Labs. I've been training there with, I couldn't do a good training of, I've been training with slightly larger images, so 640 pixels on a side with efficient at D3. I couldn't do that, interestingly, on the previous hardware I had access to, which only had 8 gigabytes of memory. So the one I'm using as, I think, is 24.
Okay.
And so that's making it easier to train more and faster. I will, now that I've got that set up, especially with the W&B integration, I'm going to do a larger training run with faster-rcnn to see whether the behavior is any different.
And visually,
so say again.
I was saying that visually you had the impression that switching to efficient det, you had better results. You can see it right away from the checking the image, I guess.
That's my sense, but the comparator would be with faster-rcnn with ResNet 50. I think is a bit closer comparison to the D3. And so because my training had been with ResNet 34, it's really not fair to compare it.
Yes. I think one augmentation that can be interesting to try is the copy and paste. So the idea is you take boxes from other images and then you put them in other ones. And there
As an
are
augmentation approach.
Sorry?
As an augmentation method?
Yes. Yeah. And it was published in just in December 2020.
Yeah, I think I saw that actually, and is it sitting there in the IceVision environment?
We don't have it yet. That's the thing, but I think it's worth considering too.
Yeah, so I was thinking this as well, either that or
the mix-up,
kind of a mix-up variant, I think would be pretty good for this domain, and it probably wouldn't help too much, I'm guessing, on a training and validation from the sort of public set, but I think it probably would make a big difference when for generalization to other environments. And actually, as I'm saying that, maybe you're right, because if I remember, you also are doing you often will do a zoom, for instance, of one of the elements. And so if you cut, copy, zoom, and paste, then you'll actually tweak things in a bunch of quite interesting ways that might enhance the detection, for instance, of titles which turn out to be smaller than you'd expect.
Yeah, one thing that I think it would be worth trying is to copy like small and medium boxes, because it might help to improve the precision there, because then there will be you are like oversampling the small and medium boxes.
Has anyone seen someone do that already? I think that's a good idea.
I didn't see it, but maybe other people in the forum can share their experience. And the other thing, I never tried it, but maybe it would be worth trying, is to take the small and medium boxes and resize them, like increase their size and then paste them.
Yeah, that's what I was thinking. Yeah.
And the idea behind that is that maybe that way you can extract the features of those like oversized boxes and detect them, and then the neural network will learn maybe even better the extracting features from small and medium boxes.
Yeah.
I have a question.
Sure.
What is the image input that you use?
In which sense?
With the shape.
This one is being trained with they are 640 on they're 640 by 640. The pages are and 640 with padding to fill in the gaps. Yeah.
So the padding, I was wondering about the padding, because all the, or is it that the pages are and well, have an orientation which is not square. So did you consider doing a crop transformation rather than padding?
Yes, I have done a crop, but I've done the, I think that, but not very aggressively. So I think you're saying they're big enough. The images are big enough that you could actually crop quite a bit. If you're getting a quarter of it, you'll still be getting quite a lot of detail in there. Is that what you're suggesting? So maybe.
Yeah, that's for one thing, but actually I was thinking about using the full perceptual field of the detector. So to see to fill the entire input with the paper, yeah, rather than padding it with ImageNet average. So in sense, like not zooming, cropping, but rather like moving the lens over the page, like this kind of transformation. This kind of crop.
I've not looked at that. In fact, this is, yeah, so sorry, let me go back. The images that I have in the data set actually are relatively low res. They're about 750 or so on the long side. In principle, in principle, they exist in much higher resolution. I could, if I was very energetic, I could probably go back to the original article sources for many of them, create higher resolution versions of the images and train with those. It would be a pretty Herculean effort for that particular data set. But I think that's, it's a good idea, but because they're under the, so I think if I remember D3, will handle 640 plus 128, so 768 square images, and I would rather have used that, for instance. One could go the other way though, and use, yeah, I get your way. You could, like, how would D2 do if you were using, the full dimension? I don't know.
But I don't know. I don't mean this full dimension. But let me rephrase, like, because since it's a non-square image, yeah, as a source, so they're like 720 per 640, let's say.
Yeah.
So like you could do the cropping, but to fit it well to the minimum. So one of them is lower, rather depending on if it's portrait or landscape orientation. So then just move the lens along the image, keeping the shorter, whether it's a height or width, and cut out square image from that.
So basically, instead of resizing, do a patch.
Patch, yeah. I was thinking like a crop, yeah, like something like this, like moving the box, like the maximum box.
Yeah, one could try that. That would the bounding boxes go out pretty close to the edges, so you'd have to trim the bounding boxes as well.
But I think the transform will handle that.
Does it? I thought that it just. If it does, then that's easy. I thought that it was aware of them, but I wasn't. What does it do if it's cropping out like most of a bounding box? Does anybody remember? Does it drop the box?
It will keep just a scratch of it, like whatever remains there. It will try to keep it, even if it's a 1 pixel, I guess. But maybe you can play around with that.
Mm-hmm, mm-hmm. Yeah, that's a good idea. Also, another thing I've not done, and I don't know whether it makes a big difference or not, is I haven't adjusted the normalization. Obviously, ImageNet normalization figures are wrong for this data set. It's if you look at the images as they show up on WNB, they're kind of pale blue backgrounds, and I suspect that's I didn't check, but I guess that's because WNB isn't no one's denormalizing them before sending them over.
Mm-hmm.
Adam,
Yeah, before
did
posting, you would have to
you have a
denormalize them.
look at why the map is not good for small objects? Because maybe, let's say, the predicted bounding box is about 10% bigger on each side than the expected one, would drop your map score by 30% already. Or something I see quite often is that the predicted boxes are a bit larger than the ground truth annotations. And if that is still okay for you, it might not be as much of a problem in some cases.
Good. Yes, so I definitely see that in some cases. I also see sometimes things just being missed. So you're saying perhaps sometimes it will be misleadingly low, but probably other times when it's really low. Is there a workaround for that? In some sense, I think it would be cute to be able to say, look, yes, that's your function, I over you, but really, if it's a little bit bigger and it's all white outside, I'm pretty happy with that.
Yes, that's the idea. It's a quite manual thing to do. You can do it and what's really going on.
Maybe you need another metric, like your custom metric for that.
Yeah. So
like when you're satisfied with large boxes, it seems like, yeah, the smallest are the problem. But what if you focus like, yeah, like increase the original image, like with what I was thinking of, like with this yeah, like the zoom, and then then the small objects will become slightly larger, I think. It's not, it's like, well, that they might be easier to detect.
Yeah, no, I will have a think about how to do that effectively. Yeah.
Honestly, like this thing, I think it's when you use the tfms.a and augmentation transforms, I think it's like a matter of changing one parameter there. Because
a crop and then some.
Yeah, something like crop and then you, like min max, something like that. I saw this. I haven't played around with this, but I think Lucas can probably, or Farid, say more about this. But
Yeah,
it should not be that difficult.
So I have a couple of thoughts on the architecture side of things. Have you tried playing around with the anchor box ratios at all? I'm not sure if it's a good idea to change them on a pre-trained model, but boxes, I think the default ratios are like 0.5, 1, and 2. But on your smaller box, I could tell like some of the aspect ratios are like 5:1 or something like that, you know?
You know what? I have not done that. I know that some people, and I know that some folks have had reasonable improvements by customizing the ratios. What I would probably do to start, and I haven't done it yet. We're interested in anyone has had done this and has a routine for it, is just do some analysis of the bounding boxes, right? So I've got a big collection of them. In order to take that step, which is a very sensible one, I'd like to, do some binning of the boxes that we see already. And then
that makes sense. Oh, sorry. Thought there. Farid recently shared this paper of the sparse-rcnn, and while just skimming through it, so there's no non-max suppression happening there, and they only produce about 100 bounding box candidates, which are then refined. Now, one very interesting detail there was that the kinds of candidates that they produce are much influenced by the training data. And it
Yes.
looks like you have a very specific kinds of candidates that would your task. So maybe once that support is there, that would be an interesting architecture to try out, because you wouldn't have to even manually try anchor box ratios, and it may just give you an improvement right off the bat.
Yeah, I'm glad you reminded me of that, because I did read that paper the other day and I thought, that sounds quite interesting. FCOS also sounded quite interesting. And I don't know, Fred, what's the status of sparse-rcnn in IceVision?
We are chasing so many rabbit holes now. So the idea is we're working on YOLO now, YOLO 5, and I think the next one will be the sparse RCNN, unless we will give it a try like we did with the corner and see if there are some surprises or no. Because, for example, with corner net, there was like a little surprise there. We have to dig more to figure out how to add. There are some extra information to handle in the model. But with, I think the one approach to that is just to give it a try, to test it in a notebook and see if everything works or no. And if it works, and we test also the inference. So we test the training and the inference, then we can put it, we can share it, even as a branch, even if we don't merge it, we can share it in the forum, and people can test it. And this is what we did with a couple of other models with MM detection. So maybe next week we can give it a try.
Yeah, so I would be delighted to give it a try when it becomes available. I think I'll probably play with my training regime a little bit before then. Does anyone thoughts about within the current toolkit of models, is anything that strikes you as being a better fit to this problem than either efficient-det or faster-rcnn?
I would try FCOS. I think that is supported only because of the anchor box aspect.
Yeah.
Yes, I agree with that.
Yeah. Good. Then can I ask you guys about? So I don't know. There are a couple of ... So if those are people wanting to talk, I'll go ahead.
Yeah, Adam, I just had a quick thought. Thanks for the talk there. I come from the NLP side of things, so this might be overly simplistic, turn it off and on kind of advice. But I'm just curious. You mentioned earlier you had questions around your training regime and like your learning rate scheduler and things like that. For the second 5 epochs you were training, like what scheduler did you use, or did you check the learning rate finder before and adjust that? And even I found like within if you're just using the default like fit one cycle scheduler, it can be helpful to play around with that schedule, and in terms of like the percent start of like when it hits the max learning rate, and also like what the min and max learning rates are. Those can be helpful. Like, sorry, this is from
but let me just I want to just poke on this a little bit more with you. So I am using the LR find, and I adjusted the learning rate. Typically, if you run per x epochs, and then you start again, the learning rate will be quite a bit smaller, and I'll use the LR find to kind of find a likely learning rate for the second portion of that. So I'm doing that, and but I'm just using the out-of-the-box Atom scheduler, and I'm not tweaking it at all. And so, tell me, what are the sorts of adjustments that you find have make a difference for you?
I've noticed, and you're using the fit one cycle schedule. Yeah. So for like resuming training, like it mightn't need to, to start all the way at like a low rate again and then decay. You could either use a different schedule or just hack that one and shorten the percent start. Maybe just give it a 1 or 2% start. So it's essentially more just like a cosine decay. That might be one idea on the learning rate. You mentioned like the optimizer earlier. I think when you save the learner and you saves with the optimizer, like the weights should be all saved, and that should be like replicated between runs. So unless there's a bug there somewhere, but I guess not. And then in terms of Atom, yeah, it's a funny one. Like people often have better success if they play around with the momentum parameters at beta 1 or 2. It can like tweak, or even also the epsilon parameter within Atom can be good to tweak a little bit. But yeah, it's hard to do all of these things right if you've got such a large training session. Training runs take a while.
Right. So then that leads to another question: is if you've got a reasonable sized training set and runs do take a while, what's the best way to to kind of work through that? These are like stupid practical issues that often are not discussed in papers, but I think a community like this has people who are working hard trying to make stuff happen, and the object detection is a particular kind of problem. It may have slightly different it's got the same knobs, but you may want to set them in slightly different places than you would for classification.
I think in pytorch-lightning there is an option to calculate every n steps, like when it comes to validation. So, and the steps is like a number of batches that you process, but this is pytorch-lightning, so it's not FastAI. But I guess maybe while looking at how they do this, it will be possible to.
It's certainly possible to do it.
But you mentioned that you were doing it already, right? Like with the time limitation or the number of batches that you process.
So I'm doing something that's roughly equivalent, which is I'm taking what would have been a huge epoch and chopping it up into small ones.
So you're actually changing the epoch.
Yeah. So instead of having one epoch that's 100,000 items, I'll do 10 epochs which run through exactly the same sequence of items, right? But 10% in each epoch.
But the callbacks in FastAI, they do have an option like at step end or something like that, at batch end. When you look at the metrics, so maybe
you can. FastAI is it's a great system. You can do anything at any time.
So maybe you could plug something there, like your logging or checkpointing, in like after not an after epoch, which is I'm not sure, but maybe that's the default for metrics calculation. But to do it after a batch, and then you can like accumulate the number of batches you have processed, and so that would do the same thing as part of pytorch-lightning has.
Yes, that's right. You could implement the capabilities that pytorch-lightning has for that, which sound like they're in many ways a bit more. There's some good ones out of the box there, actually. Each of those systems has some things that they do, relatively a little better or a little worse. It'd be nice to see people. It's kind of terrible to copy and paste everybody's best ideas in both ways, but a little bit.
All we do.
So, Adam, you said that you will effectively one actual epoch over all your training data was split into 10, right?
Yeah.
How many epochs do you like effectively? As in, how many times does the model actually see every item?
So I hope many. To date, I've only so this is pretty new capability, and I've just started using a server that has enough oomph to get through it in kind of a reasonable amount of time. And so I've only done training runs on 100,000. That's 100. What is that? 100,000 records, which is a million bounding boxes, I guess. Yeah.
Okay. Because right. So, to say the other thing I had in mind, which is a simple tweak that I found in the optimizer and scheduler that's worked positively for me is shift from Atom to what FastAI calls Ranger, which is like it's wrapped around Atom. It's the look ahead optimizer wrapped around Atom, and FastAI provides that out of the box. It's called Ranger.
Yeah.
And the scheduler that works really well with that is fit flat costs, which is it fits it with the flat learning rate until a certain percentage of the number of epochs, and then it does cosine decay. That might be a bad rabbit hole for you to jump down into because of the amount of training time it takes. But it's worked really well for me in the past, and like it's my default, the default one I use, and it's what FastAI uses when for all their benchmark beating training runs on ImageNet and all of that. So yeah, and the last point that I wanted to address that you mentioned is, like in what order do you try all these tweaks when it takes so long to run experiments? And that's a really tough one and to grapple with. What I like doing is like, I follow my intuition and kind of see like, okay, what's the most obvious one to make a difference? Over here, like I think FCOS is a good one.
Yep.
Only because of the anchor box stuff. And also another thing to factor, like how much effort will it take for you? Like FCOS should be trivial because IceVision solves that problem for you. And it's a tricky one for sure.
Yeah, that's so. It's I would. This is one of those sort of areas. Is kind of that kind of what are the tricks that kind of work for you in what order is something I'd love for us as a community to get to a point where we can sort of write some of it down, have some discussions about that, because that could make a big impact on everybody in the community's practice on a day-to-day basis.
Yeah, I think that's a great point. It would be super interesting actually if we pick as a community, a few small data sets which aren't resources to train, and we do some systematic experiments. Like one of the interesting on one of the help channels was how the smallest bounding boxes are the hardest to detect, and would just like artificially increasing the size of those increase the score. Like that's something that could be huge in practice if it works. But yeah, like I think doing systematic experiments across a few data sets would be great. And it's kind of what FastAI did when they were starting off, which is why they have their whole bag of tricks to state-of-the-art results. And having that for object detection would be super cool.
Yeah. One thing as well, definitely I'd agree with the Ranger suggestion for the little bit of image work I've done. Like it's always kind of performed best, and I've found Ranger can also tolerate maybe a slightly higher learning rate than you'd think, or compared to like fit one cycle. So maybe don't be afraid to push the learning rate there a little bit. And the second thing, you mentioned you've got your 2 runs and weights and biases. I don't know if you saw in the docs, there's actually a way to resume your run. So I just shared a link in the chat there to the docs. And you could.
I saw that in the documentation, and I haven't had enough time to figure out how to do it. To try it out. Yeah.
Cool.
Yeah. Thanks. Yeah, I saw that. I saw it yesterday.
But did somebody manage to like do proper checkpointing and resume in FastAI, because that's one of the problems that I had, and that's why I like actually moved to pytorch-lightning, because there the checkpointing is brilliant.
No, I think that,
Last I checked, which was on FastAI 2.11, I think. Now it's on 2.27. Like as of 2.11, the checkpointing didn't save the optimizer state, so you were only saving the weights. But I do remember there being a discussion, this was maybe 3 months back, about how that's something someone should tackle, but I don't know if there's been any progress there.
And for the sake of logging, also the current epoch, like FastAI always starts from 0, if I remember correctly, and that's just something that doesn't go well with WANT.
even if you do the restart, it starts again at 0.
Yeah, and then you overwrite your that was a pain.
Yes, I hated that. This is the save model callback, where it's where you set it to save it at every epoch, and it will overwrite the previous. I filed the issue on that one.
The 0, that was the worst. Like, it starts and it just like rewrites everything because it has like the new metric that it just calculated and it thinks it's the best. Yeah, I've been there. Yeah.
On that very frustrating. That was what a bad idea.
Yes.
Yeah. No, I've started now. I name my checkpoints to the minute, and I'm very careful to put files, the models that I like, into a separate directory, so I don't lose anything again.
I have a question regarding the training. Do you do it? You said you use Jarvis Lab, so you're training in the notebook. Then is that correct?
The training. Say again.
Are you training in a notebook because that's their default?
No.
So you use a terminal and then like script training. Okay.
Yeah.
So if you use script training, I found.
Go ahead.
I found that the FastAI's coco-parser, I think it was called. That was a decorator for a function. It was really handy, and I really liked how it introduces the arguments into your training script. Really easy to use, and it looks clean in the code. So definitely give it a go. I use it in my scripts for training from the console.
So I also started using that, and I think I saw it in one of your scripts. So thanks for that. And I found an awkwardness with it, and you may know a solution to this, which was that I have a set of default values for parameters from a configuration file, and a bunch of presets that I use, so I can say I want this big model, this little model, what have you. And then I've got the command line, and I don't want, if the command line values have been provided, they should overwrite. But if they haven't been provided, they shouldn't. Yeah, and I didn't find a good way within the coco-parser to ask the question: was this parameter actually provided on the command line? I figured a workaround for it, but it's super ugly.
So you're saying that it doesn't. Well, I'm not sure if I understand correctly. So it's when you pass that argument, it should take it, but if you don't,
so
you should use the default, right?
Yeah. So the problem is they're kind of two sets of defaults. Okay. So the way I've got it set up, and there are many better ways of doing this, I'm sure, but I can specify a preset, which is like my standard way of doing faster-rcnn, but then I want to tweak it for this particular machine and mood I have, right? So I've got defaults that are like defaults that apply to the presets. Then I've got the presets, and each one of which provides default values. And then I've got the command line values. So a command line value should override a preset, but it should take its default, but it should display a default, which would be the default if you didn't pick a preset. Does that make sense?
I got a little confused there.
Sorry, I mean,
but
too confused. Go ahead. Sorry.
No, so I don't know if this is helpful, but like if you you can. I see that you've set everything to none now, so that actually makes it a keyword argument on the command line.
Yeah.
You can. So what I do is you either set the default values there, or like if you don't set equals to none at all, it becomes a positional argument, which is one thing that I found pretty awkward about the tool as well. But I also use the workaround of setting everything to none. And yeah, I'm not sure if there's a way around it with the way it's currently implemented. I did try modifying it, but like that broke a bunch of other stuff. So
are you saying that all of them are positional arguments?
If you don't write equals none, then it becomes a positional argument that's required.
Could you demonstrate, perhaps?
So I'll just say that the way I've ended up doing is providing none as the default, which lets me see if it's been passed easily or not. And the problem with that is that, you know, your defaults are many things, you know, if it's aren't interesting. So this one, I didn't set it to none, but all the other ones are set to none. And so they don't actually show you your default values. So I've, if that makes sense. It's just a little awkward. I'm sure there's a better way of another thing I don't like is that you have to say true if you want to use you can't just leave it without a value. And so what I've ended up doing to deal with the defaults thing is I have a way of just listing all the preset values.
I think that there are some solutions to that, like in the documentation. I think I saw something like you can just pass it as a flag, like -s. But I haven't done it myself. I think it should be possible. I'm almost sure that I saw it.
I suspect that, you know, yes, and it's that interaction between call-parse and arg-parse, and it took me a while to get my head around it. And I haven't come back yet to tidy things up to reflect the new understanding of how that stuff works. Yeah, it's I don't know how others are. You know, I was kind of there've been years in my life where I've written a lot of code and years where I haven't written a lot of code. And there've been quite a few of that second category in the last few years. And so that means I feel quite rusty with this stuff, right? It takes me a while to build up the sort of typical practices of, you know, every time you write a script, you always use call parse and you do it this way and it works, it's fine. And so I consume surprising amounts of energy getting that stuff to work in a way that feels satisfactory.
On another note, I want just to get back to the normalization. And in FastAI, if I remember well, you can use batch normalization if you don't want to use, for example, ImageNet normalization. And it looks like ImageNet normalization is not fit for these kind of data sets because the distribution is completely different and so on. So maybe you can give it a try and use the batch normalization there and see if you have better results or not. So the idea is that you take your batch and you normalize it. So it's done by FastAI instead of just taking the predefined values that comes from ImageNet. So
right, I'll check that. Thanks. That's I remember this is a thing, but I've not used it before.
And the other remark is about Jarvis Labs. I don't know if you are using their discount. There's a discount for FastAI users. There's a 20%. So in case you are not using it, it's worth
very good.
checking. And we have been contacted by the guy from Jarvis, and we are trying to evaluate and give him some feedback. And actually, Pavel is doing that now, because he has also experience with the data crunch, and we will see afterwards if we have like any information. Maybe we will try to ask the same thing for the IceVision community to have same rebate there.
There were a couple of awkwardnesses which I think they're working to improve.
Mm-hmm.
But it's, the equipment is modern and fast, and it's been very solid.
Good.
So I've been actually quite happy with.
Adam actually has. It seems like. Oh, sorry.
Say again?
It seems like you have some experience now working with Jarvis Lab. As you said, you're using it, because I only played around for a couple of hours. I haven't had time to get back to it. So yeah, maybe we could actually exchange some of the thoughts on that, so it would help me, to get some of the ideas, to get like a report on it. Yeah,
great idea. If you want to be in touch, you can get a hold of me pretty much. Well, I'm in outside of London, so I'm mostly awake. European.
Great. Yeah, I'll message you about that for sure.
Thanks. Good. You know what? I'm not sure when we were supposed to stop, but I think we've almost certainly exceeded whatever timing we had intended to have. So I think I suggest we draw it to a close. I really appreciate y'all's attention, and some of these suggestions I'm going to follow up on them over the next couple of days, and maybe I'll pop some comments into Discord about how those things have gone. Those are some really good ideas. I'm looking forward to the sparse RNN thing, but definitely give a spin. And there's some really good ideas about training. Definitely some good ideas about tweaking the optimizer. And I'm glad someone, was that Morgan that you had brought that up, because I had at some point meant to give Ranger a spin and had put it slipped off the list. And I'm really glad to hear that you've had good experience with it. So I will definitely give that a try, perhaps with the fit flat cosine scheduler policy.
Great. Thank you very much, Adam. That was really an awesome presentation, and we really learned a lot, as in the other IceVision presentations. So thank you very much for sharing what you already accomplished, and hopefully we will continue the discussion in the forum and have the feedback from other IceVision users there.
Great. And thanks so much for organizing these weekly things. They've been really good.
You're very, very welcome. Thanks to everybody for showing up, and we will see you next week in another IceVision presentation, hopefully. Have a good evening or have a good afternoon, and see you next time.
Bye now.
Thank you. Bye.